Let's experimentally verify inertia with the help of Galileo's inclined plane. Galileo was a scientist who gave this particular experiment. So in this experiment, we're going to make use of two planes. That's our plane 1 and this is our plane 2. So in all of the variations, what we're going to do is we're going to let go of a billiards ball from a particular point. And we're going to make a mental note of, if not on a paper, to what height it went. That's it. That's the experiment. So let's read the procedure. A billiards ball is let go down an inclined plane, plane 1, from a fixed point, and that's the point. Observe to what height it climbs up at the other end on the inclined plane. So we have to make a mental note, if not I'll draw it over here, and you guys also should observe and make a note of it, right? So that you can verify if I'm doing it right or wrong. Then the experiment is repeated by changing the slope of the inclined plane. That is, this is the slope, right? This particular angle will give the slope. So put it in simple words, we're going to reduce this angle. Okay, we're going to reduce this angle and see what happens. So let's begin. Let's watch the first video and make a note of till what point it reaches. Please have a look at this. It reached to a height of around 15 centimeter. Is it not? Okay, the next one. Over here, it reached a height of 20 plus. The third one. It reached a height of 40 plus. Is it not? And the fourth one. Well, it went behind 50. So what is happening? The billiards ball, it's covering more distance as the slope of the second plane reducing. Is it not? So with this observation, Galileo, he concluded that in an ideal case, the billiards ball would continue to travel forever, trying to reach the same height that it was released from. That is, we require a plane to be frictionless. The ideal case here is all of this plane should be very smooth. There should be no friction. So if I happen to let go of a billiards ball from a particular height, it keeps traveling till it reaches what? Reaches this height. Till it reaches this height, it will keep going. That's the ideal scenario. Of course, here we are not looking at an ideal scenario, but for ideal scenario, it would have gone the extreme being this. So if this point is not reached, if it's not reachable, like over here, if this plane, the height was not reached. So ideally, if this plane just existed and not this plane 2 did not exist, from plane 1, it would have continued traveling forever, trying to reach that height. If it reaches that height, then it stops over there and comes back. If it does not reach, it will keep going. Again, this is an ideal scenario, not practical. So this is your inertia of motion, right? So this is your Galileo's inclined plane. You guys have to make a note of it, a running note,